Hello, welcome to another section of the StaadPro V8i tutorial. And in these tutorials I'll be taking you on small problems that we are going to find or we are going to solve using the application or the software StaadPro V8i. And one of the problems here is going to be a simple beam. For us to analyze a beam of dimension 350 millimeters by 250 millimeters as shown in this figure. Now all the supports here are fixed. As you can see from your left to the right of the beam, you can see that the support here is fixed. The one at right here on the 5 kilonewton load is fixed. The one at the 7 kilonewton load is fixed. Then at the right support, all of them are fixed. So they say loading conditions are shown in the figure itself. So I don't need to explain much for you to see that all of them are fixed. From the figure, if you've already done your manual calculations on an analysis of beams, you will know that these are fixed supports. And from this figure, you've seen that the first span here is 3 meters, the second span is 4 meters, and the third span here is 4 meters. And you can also see that from the figure here, we have our first member to be 3 kilonewton per meter, a uniformly distributed load. Then our second member is going to is a 5 kilonewton meters. Then our third member is 3 kilonewton meter. Then we also see that we have point load at each of the nodes. Here we have 5 kilonewton at this second node, and we have another one 7 kilonewton at this the third node, to say, or the other nodes. So we using product structure, we are going to analyze this simple beam. So the first thing, after you must have launched, or you must have, let's say you have opened your StaadPro V8i application, the first thing that you are going to do is for you to click on new project. Now before then, let's check on configurations. I'm teaching from Nigeria, and in Nigeria we are using the British standard codes. So right here you click on your StaadPro, you see what they write, start default design codes. Now we have the place they say select default steel design code. Now in Nigeria we are using the British standard code BS5950 when we are designing for beams. Then for concrete we use BS8110, and for shear wall designs we use this. So I've already set this. So if you have your application right there with you, you can set the standard code that is used in your country. I'm from Nigeria, that's what I'm saying. So I've actually set my own, and what I'm going to do now is to click on apply. After that, then I've now click on accept. So when I'm done, everything is set. So the next thing for us we are going to do is for us to click on a new project. And when you click on new project, you see a place the right plane. Then you select your length and the force unit. Now from our figure here, you can see that most of the units here are in meters and in kilonewtons. So let's get back and select it. Now this one is already in full, so let's select meters. Then right by your right, you see force unit, select kilonewton. Then there's a place you have to select the location where your work is going to be stored. Just get me right, say where your work is going to be stored. You've been working on some project, where do you want the particular location to be stored? So click on these 3 dots, the buttons there. Then you can then choose a place that you want your files to be stored, and I will select my documents. I'll choose documents. Then I'll select this particular place, 400 level courses. I'll store my files there. So when you are done, you can then name it. Let's name it as simple beam 1. You can give it that name, or any name that you feel like giving, you can give it that name. So when you must have done that, the next thing for you to do is to click on the next button, then click on OK. And the next page I come say add beam, and there is just ignore it and select the add beam. Then you click on finish. When you are done, you are brought to a particular page or an interface where the work is going to, where we are going to further our work. So having seen this, we have seen that this grid is not it's not in the right direction. So on top here, you click on view from, make it look straight. Now looking at this and looking at what you were giving, we can see this is running from 0 to 10. But from our question, if you calculate this 3 meters plus 5 meters plus 4 meters, the total should be giving you about, that should be about 12, right? 3 plus 4, 7 plus 5, 12. So we are going to add more nodes here to complete 12. So what you do now, click on your edit button here, then you will see a place written 10. So just add 2 more to complete. Then when you are done, you click on OK. So when you are done, the next thing for us to do now is for us to add the beam from here. So what you now, just click on your first point and drag it. The first distance is 3 meters, so you drop it at 3. Then from 3 you move it over to your next one is 5, so it's going to stop at 8. That is 5 plus 3, 8, and the next one is 4. So 1, 2, 3, 4 is going to complete your 12. When you are done, you can tap your escape key, and here you are done. Right at the left panel here, you see beam. Click on the beam, then this is your beam, and each of the spans are here. Span 1, 2, and your span 3. Now the next thing for us we are going to do is for us to give the dimensions of the beam. Here we have 350 millimeters by 250 millimeters. So let's add the dimensions to our beam here. You click on general, then you click on properties of the beam, then you define. Right here you see where it's written define. We are going to define the beam, and it's going to be a rectangular form. So since we are given in millimeters, so to change this to meters, it should be 0.35 by 0.25 meters. When you are done, you click on assign, then you click on your close. Sorry, made a mistake. You're supposed to assign it. So what you are going to do is you are going to select the whole beam now and assign to selected beam. Then click on yes, and you've successfully, you have successfully assigned these dimensions to the beam. So what next? What are you going to do? And what we are going to do now is for us to add what we are going to, we are going to add each of these supports to our beam. Right here by the left, you see where it's written support. You click on your support, and right here click on create support. They said all our supports here. From the question it was said that all our supports are fixed. So what you now do, click on add support. We have fixed foundation, pin, fixed board, enforce, and so many other supports. So use a fixed support and tap on it, select your whole, select the whole beam and assign the support to the selected nodes here. So we are going to assign it to it, and all the supports have taken its place. So the next thing we are going to do is for us to assign these loads, the UDL and the pointed loads, to the beam itself. So let's visit back this. So right here you see load and definitions. What I just click on this load and definitions, and right here click on your load cases, then you click on add. So let's assume that our load is a dead load, and let's define it as title dead load. Click on add, then click on close. You tap on your dead load and click add. Then we have from the diagram here, we have a uniformly distributed load of 3 kilonewton per meter. Now as you can see, the force is acting from up till down in a y direction, so it's going to take the negative form. So, and it is acting on a member. So what we do now, let's click on the member 1, then click on uniform force, yes, and the uniform force is minus, it should be minus 3 kilonewton, minus 3. so we use -3 and leave everything. Then you click on add. When you've done that, the next one we are going to add is the point load. Here is acting at a node, so it's a nodal force acting at a node of 5 kilonewton. So we go back to our nodal load. Then in the y direction, it's acting in the y direction, so it is minus, what is the unit, the magnitude is 5, so use -5. Then you click on add. Then we have another UDL here, which is 5 kilonewton. So let's go back to our member load, and we have our 5 kilonewton. Click on add. Then we have another one at this node, -7, and it is at a nodal load, so -7. Click on add. Now we have another one of 3 kilonewton per meter, but as you can see now, the two of them are the same they are the same magnitude, so you can decide to ignore that. Then you click on your close. So the next thing we are going to do now is for us to apply each of these loads now to the selected beam. So how do you do that? The first one is uniformly distributed load, so you tap on it. Then what you are going to do is you are going to select the member, and we have beam cursor and we have the nodal cursor. We are going to use the beam cursor and select this beam. Then you select this, assign to the selected beam. Then you click on your assign button. So the next one we are going to assign is the 5 kilonewton at the node, this particular node now. So let's select on that. Then you tap on your node's cursor right here, at your top left on one of your bars here. Click on it, then click on this node, assign to selected node. Click on your assign, then you click on yes, the load is applied there. So there's another UDL here at this particular point, so you tap on that. Then you select your beam cursor, then you select this particular span of the beam and assign to selected beam. Click on your assign button. Then at this node, you can see we have 7 kilonewton, so we are going to apply it at this joint here. So -7, 7 kilonewton. Then you select your node cursor, then you select on this particular place, assign to selected node. Then you repeat the whole thing till you reach this one. And this one, we have said it before that the last member has the same uniformly distributed load magnitude. So what to now, we have to go back to our -3 uniformly distributed load. Then you select your member here, assign to selected beam, assign. Then you click on your yes. So when you are done, the next thing we are going to do now, we've assigned all the loads and and the dimensions to our beam. So we are going to calculate this after you must have done everything now. So what we are going to do is we are going to analyze right here by left, and you see analyze and print. So when you click on that, you leave it at default, no print. Then click on add, and when you are done, click on close. Then at your top here, you see where they write analyze. Then click on the analyze and run analysis of the building. You can save it, and let's run the analysis. So you wait for the beam to run itself. Well, as we are running the beam, it's going to take some time depending on how fast your system is. Your system, it all depends on your system. So now I have 0 errors, 1 warnings, and 0 nodes. So in your case, if you had like maybe 1 error, 2 error, depending on the number of errors that you had, that there's a problem. But here we have 0 errors. That means our analysis is complete and it is perfect. So we click on go to post-processing mode. So you click on go to post-processing mode, then you click on done, and click on OK. So when you are done, this is the analysis of everything that you have done. This is the whole analysis. And click on your beam and click on the graph, and the forces are all here, and click on each of these members to to look at what is happening, and click on each of these to check what is happening. So at the end of this, we have successfully analyzed this beam, the dimensions of this beam. Given the dimensions, we successfully analyzed it. So thank you for watching my tutorials. This is just a simple beam, as you can see. So in my next tutorials, I will be taking you to analyzing continuous beams, and furthermore I will be taking you on how to analyze frames, beams, and columns, and so many of them. So thank you for watching my tutorials, and I think the time we had is worth it. So please, you can subscribe to my YouTube channel, Danny Tutorials. Right below there you see a red button, subscribe button, so click on it. And if you like this video, I would really appreciate